Good evening students. Welcome to one more class of Yupp Master School Foundation. So, previous class we have discussed about natural numbers, whole numbers, even numbers and odd numbers we are going to discuss in today's class. So, we have done some basics of basic problems on whole numbers, natural numbers and even numbers as well, okay? And integers also we have learnt in the previous class. So, today's class we are going to learn about odd numbers, right? So, what are odd numbers ma? See, suppose what is even number, let us recollect. So, even number is nothing but whenever a given number is being divided by 2 and the remainder it leaves 0, then that number we call it as even number. And general form for even number is what ma? 2n, right? So, let us write down whatever we have told, okay? So, even numbers general form is 2n, right? In place of n, if I can take odd number as well. So, I will be getting 2 ones are 2, 2 twos are 2 into 1, 2, okay? 2 ones are 2 and then see 2 twos are, it is 4, here 2n, okay? All this are multiples of 2 threes are 6. So, general form for even number. So, in general term multiples of 2, in 2 table we are having 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10, like that, right? So, these are multiples of 2. So, all multiples of 2 are divided by 2, indirectly multiples of 2 are even numbers, okay? Now, coming back to our odd numbers. Odd numbers are nothing but numbers which are not divisible by 2. We are not talking about 3, 5, all that. To differentiate between odd and even, we are going to use only 2, okay? So, the general form will be 2n plus 1, okay? This is the general form, okay? And then we will see one example. So, I will take 7. 2 threes are is 7, right? 2 threes are is 7? No. 2 threes are is 6 and the remainder it leaves is 1, okay? Remainder is 1. So, 7 is it a odd number or even number? Even number only, and I will write this 7 in terms of 2n plus 1. So, see here 2 is being multiplied with 3 and remainder. I got 7, right? Understood na? General form. So, the general form for any number. So, sir, if I write in place of n a even number, then see here 2 twos are plus 1, 4 plus 5 plus 1, 5. Here n I have taken a even number, n equal to 2, but still I am getting a odd number which is 5. 5 is it divisible by 2? No. Remainder it is leaving 1, okay? Now see here ma. So, we will discuss properties about odd numbers. Generally, odd numbers are the numbers which are not divisible by 2 and when it is being divided by 2, it leaves the remainder 1. And the general form for odd numbers is 2n plus 1. Now, see here, yeah, integers which are not divisible by 2 are called as odd numbers. And see here, odd numbers are denoted by the letter O, can we tell? No. So, we will come to that afterwards. See, generally we are using capital E for even numbers. So, O will be using for odd and the general form for 2n plus 1 is the general form for the odd numbers, right? Where n is any integer. So, see here, odd numbers are denoted by the general form 2n minus 1 or plus 1. So, see here 2n plus 1 also we are having 3, but 2n minus 1, see here 2n minus 1, if I am making 1 here, 2 2 minus 1, 1 I will get. Now see here, 2n minus 1 if n equal to 3. Six minus 1, 5. So this equation, it is satisfying for 2n plus 1 as well as 2n minus 1 also. Okay. See here, if I am making this one as 2, n I am taking it 2. So I am getting what? 2 2s are 4, 4 plus 1. When n equal to 2 as well, in 2n minus 1. So 2 2s are, which is 4 minus 1, 3. So be careful with the expressions. They might use 2n plus 1 as well as 2n plus 1 also. Okay. O is the general letter which is being used for odd numbers, right. Now see, the range of odd numbers is minus 5, minus 3, minus 2, sorry, no minus 2, it is minus 1. See, difference between any two consecutive odd numbers will be 2 only. So see here, so 0 in between, 0 is it odd? No, again no 0, 0 is neither odd neither even. Okay, no 0. Now see here, 1, so see here, these are negative odd numbers, these are positive odd numbers. Okay. So we will cross check this one. If I am substituting n value as minus 1 here, minus 1 and again minus 1, plus into minus, what ma, minus, right. This operations on numbers, integers you must have heard. So this is minus 3, which is a odd number. Okay. Now we will test this minus 1 in 2n plus 1 also. So minus 2 plus 1, which is minus 1. Okay. So be careful with the general form also. Okay. Now see here. So all natural numbers that are divisible by 2 are odd numbers. Is this statement true? Is this statement true? Odd natural numbers which are divisible by 2 are odd numbers. What is it? It is controversial of our statement, right? So natural numbers which are divisible by 2 are even numbers, not odd numbers. So this statement is false, ma. Okay. The difference between any two consecutive odd natural numbers is always 3, it seems. So we will take some odd numbers here. Erase all. Now see here, I will take 5, 7, 9. Okay. The difference between any two consecutive odd natural numbers. So I will do the difference. 7 minus 5, what ma? 2. 9 minus 7, what is the difference? 2. Is it always 3? No, not at all. 2. False. This statement is false. Now see here. Odd natural numbers are not multiples of 2. Odd natural numbers. It is correct only, na? So see here. Odd natural numbers are what? Natural numbers are ranging from 1, 2, 3, 4 until infinite, right? Now see here, 2, So 2, does it come under odd number? No. So I will first write down the range of odd numbers, okay, not range of odd numbers. So see here, n is divided, n natural numbers are denoted by the letter n and its range is 1, 2, 3, 4, 5 dot dot dot, okay, it goes on till infinite. Now coming back to this statement, odd natural numbers are not multiples of 2. So odd natural numbers are what ma here? 1, 3, 5, 7, goes on like this, right. So see here, odd natural numbers are not multiples of 2. In 2 table, do I get 3? 2 ones are 3? No. 2 twos are is 4, 2 threes are is 6, right. Am I getting these numbers? No, this statement is correct only. Odd natural numbers are not multiples of 2. So this is true. Here this one was what ma? The difference between any two consecutive odd natural numbers is always 3. I proved it, it is 2. False. So see here, there are infinite natural numbers. Infinite natural numbers, I missed the letter odd. There are infinite odd natural numbers. Yeah, 1, 3, 5, 7 goes on infinite. Infinite odd natural numbers. So this statement is true. Okay. Now comes the prime number. What is prime number ma? A prime number is a number which is being divided by itself and 1. Such numbers are called as prime numbers, or else prime numbers are those numbers which is having only 2 factors, and the factors are the number itself and 1. Okay. 2 is the only even prime number, remaining all are odd. This is the general thing which we have learnt in our 6th standard as well. Okay. Now coming back to this one. In this one, see ma, you are having 2 ones are 2, okay, 3 ones are 3, 5 ones are 5, 7 ones are 7, 11 ones are 11. Factors for this one, see, factors for this one is 1, 2, 1, 3, 1, 5, see the ticked part, 1, 7, 1, 11. So my question is like, 7, does it come in any other table? No, right. 7 ones are 7, 1 sevens are 7, except this I cannot find 7 in any other table, and 11 also, 11 will come in 11 table only, 11 ones are 11 and 1 11s are 11, like that, prime numbers. So see here, the number that is greater than 1 and divisible by itself and 1, yeah, this is true only na. In this example, the number which is greater than 1, yeah, 2 is greater than 1, 3 is greater than 1, 5 is greater than 1 and 7 is also greater than 1. So the number which is greater than 1 as well as divided by itself and 1 only are called as prime numbers. Yeah, true only. The definition is this one, okay. Prime numbers are being denoted by the letter P, and in prime numbers are we having any negative number? That is also point. No negative number in prime numbers. So these are the numbers in prime. P is denoted for prime numbers. So 2, 3, 7, 11, so on, goes on. So the number which is satisfying the condition that it is divided by itself and by 1, it is called as prime number, okay. Now except 2, all other numbers are odd numbers. So see here 2 divides 2 here, but 2 does not divide 3. Remainder 1. For 7 also see. Remainder 1. 11 also same condition will come. So that statement states that 2 is the only even prime number, remaining all are odd, okay. There will be infinite number of prime numbers. See, after 100, thousands will come, thousands, then 10,000, lakhs, millions, trillions. There are infinite number of prime numbers, yes. Now see here, prime numbers, again this chart has come. So see here, I will elaborate it again. 2, can you find it here? See, here 1 2s are 2 and 2 1s are 2. Except here you cannot find 2 here. and 3. 3 ones are 3. Here see. 3 ones are and in one table. Okay. Now see here. 5 ones are 5. So in 5 table you will find 5 ones are and in one table. In any other table you are not going to find 5. 7 also same thing. 7 ones are 7 and in 7 table also you are finding it. Understood Nama? For your deep understanding in this one. 11 ones are is 11. So see here, in 11 table you will have, and again unfortunately there is no 11 table here. So see, understood na difference? See, any 3, 5, 3, 5 and 3, sorry, it is 2, 3, 5, 7 and 11. These numbers are not found in any other table except one table and the respective number. Okay, that is what I want to tell. Now see here, 2 is the only prime number that is also an odd, it seems. What rubbish. 2 is it a odd? 2 is the only prime number that is also an odd number. So this statement is controversy, right? If it was even in place of odd, then it would have been true. 2 is the only prime number that is also an odd number. This statement is false. Okay? Every prime number is not divisible. Every prime number is not divisible by only two natural numbers. One of them is the number itself and the other one is 1. See here, this statement is controversing with itself only. The first statement it says the definition. See the second statement, one of them is the number itself and the other one is 1. True. Every prime number is not divisible by only two natural numbers. What is this? Partially true, partially false. Okay? So this one is totally false. See, I am telling you the difference here. Every prime number is not a divisible by only two natural numbers. Is not. If not was removed from here, then the whole statement would have been true. Here is not divisible by two natural numbers. See, prime number is a number which is divisible by only two natural numbers which are 1 and itself. Here he is telling one of them is the number itself and the other is 1. The prime number is not divisible by only two natural numbers. If not was removed, then the statement would have been true. See, this type of technical questions will be asked to confuse you. Okay? Now see here, 3 is a prime number as it is only divisible by 3 and itself. Yeah, indirectly he is giving an example for prime number. So this is true. Okay? 1 is the smallest prime number. Is it 1? Is it a prime number? No. 2 is a prime number which is the smallest prime number as well as even number. 1 is neither prime neither composite. So this statement is false. Now see here, next is composite numbers. What do you mean by composite numbers? Composite numbers are those numbers which are having factors other than 1 and as well as itself. What does it mean? Whatever the words which I have told you, what did you understand? So let us elaborate. So see here, 4 having more than, composite numbers are the whole numbers having greater than 2 factors, greater than 1 and none of the numbers. See, composite numbers are whole numbers greater than 1 and none of the numbers is a prime. Some new definition they have told. So simple language which we can remember is, see here. So see here, example of 4. 4 we will take. So 4 it will come in one table. See, first factors I will write down 1, 4, okay, because 1 4s are 4. And again 4 will come in 2 table as well. Okay, 3 table does it come? No. 4 ones are 4, close. So see here, prime number, what was the condition? 1 and itself. So means what? this should not be in prime number. See, one more number has interfered between 1 and 4. So, this is a composite number. So, factors of 4 are what, ma? 1, 2, 4. So, this is a prime, this is not a prime number, this is a composite number. So, it is not satisfying the condition of prime number, it is having extra 2 2s are. If there was no 2 2s are equal to 4, then it would have become a prime number, okay. So, the same point they are telling, 1 is neither a composite neither prime it seems. So, 10 also, for 10 also see, I will write down the factors of 10. So, factors of 10 ma. So, see here 1, 10s are, 2, 5s are, 5 2s are, and again 10 1s are. So, 10 is appearing in 2 table as well as 5 table also. So, this is a composite number. See, if these two statements 2 5s are and 5 2s are was not there, then it would have been satisfied the condition of prime numbers, but still 10 is coming in 5 table as well as 2 table also. So, this is an example of a composite number. 10 is having factors other than 1 and itself. So, 2 and 5 are the other factors of 10. So, see here, okay. Now, for your better understanding, now see here, same thing. We will start with 4. We will start with 4. So, see here, 4 I am having in 1 table. 4 is also there in 2 table. And again 4 is coming in 4 table. Okay. Anything else? See here. Now, we will start with 10 now. 10 is coming in 10 table. See here. 10 table, here it is coming 10 table, 2 5s are 10 here, here 10 came, see, and again 5 2s are also 10, okay. Now, we will go with 16 or 8, so we will use different color now. So, for 8 we will go do it with green color. So, see 1 8s are 8, in 1 table it has come, and again here it has come 8, 8 also it came here, see here, 4 table also it is there, 8 here. I hope you are able to understand. So, for prime numbers, this part we call it as multiples ma. So, 1 2 3 4 are called multiples, here multiples of 2 are called 2 4 6 8 10 like that. So, 8 has come like this. Now, see, we will check 9 also. 9 came in 3 table also, see here, in here 9 came, and again in 9 table also 9 is there here, see 9 came here also. 25 also we will check here, see 25 5 5s are, it will be coming in 1 table as well as 25 table also, okay. I hope you have understood. Okay. Now, see here, we will solve some objective type of bits. Every even natural number that has more than 2 factors, every natural is it there? No, every even natural number that has more than 2 factors is called a composite number. Every even natural number. So, let us think about why is that they have stressed the word even. So, see here, I will consider 3 here, 5 here, 7 here, 11 here, 13 here, 17 here. These are examples of odd, right? And these are examples of prime numbers also, right? So, every natural number that has more than 2 factors, every even natural numbers, even, again I am stressing, every even natural numbers that has more than 2 factors is called a composite number. Where has 2 gone beta? See here, where is 2? 2 is also a prime number, right? How can he tell 2 is a composite number? Every even natural number, 2 is a part of a natural number as well as it is a even number. 2 is a even number. See here, 2 is a even number, 2 is a prime number, 2 is a natural number, 2 is a integer as well, 2 is a whole number as well. Okay, 2 comes in even numbers, prime number, natural number. Every even natural number that has more than 2 factors is called composite number. But he has forgotten about 2. He has given one statement. So this statement is false. Seema, you need to be very careful. Because 2 is even number here. 2 is even, which is prime. Okay. So see here, every even number greater than 2, every even number greater than 2 is a composite number. Let us think about. So 2, 4, 6, 8, 10, 12 are examples of composite numbers, right? Every even number greater than 2 is not a composite number. Composite number it is not, it seems. These are examples of composite numbers. These are composite numbers only. Is this statement true? No, right? Every even number greater than 2, these numbers are greater than 2 is not a composite number. If he would have written, he would have, the author would have not written not there, then the statement would have been true, but it is false. Here not is there, be careful, okay. Now see here, 2 is a least composite number it seems. Composite number, first of all, 2 is, no, 2 is a prime number. 2 is prime. It is not composite. So this statement is false. 2 is a least prime number, then it would have been correct. But 2 is a least composite number they are telling. So false, right? 1 is a prime number, 1 is a prime number as well as a composite number. What is it? What is it? Not possible, right? 1 is neither a composite number, neither a prime number. That was the actual statement, but they are trying us to confuse us. 1 is a prime number as well as a composite number. False, ma. It is false. Okay? So I hope you must have understood the concept well, and at the same time how to address the competitive part. Okay? So however, this brings to the end of today's class. We will meet tomorrow. Until then, keep watching Yupp Master.